top one there, Paul. Okay. My colleague is Mike in the audience. Put your hand up, Mike. So we'll both be here to answer questions at the very end. My background is cybersecurity, computer networks, where I used to be at home. And now I'm really interested in the environmental side of things. I was really, really pleased to hear, where are you? The guy who's just up, where is he? Oh, hi.
Yes, hi.
Really, really, really pleased to hear this because it needs to be taken seriously. We need this environmental sensing, and I'm well into it. I've been into it for a number of years, but kind of cybersecurity and networks and the university got in the way. Now it doesn't. So this is really good. And I'd love to talk to you afterwards about a number of different things related to what you were talking about. Okay, because effectively, I can press the right button here.
Go right, go forward. There you go.
All right, doesn't have anything on.
No, it's right.
Okay, so we have a problem, all right? We have a major problem in the UK. This is from the Environment Agency data for the year 2022. It's not up to date. 40% of lakes and rivers achieve good ecological status. Okay, good isn't excellent. Good is, it should be better, and that's useless because it's only 40%. There are loads of chemical contaminants in the water. There's 2 stretches of river with bathing water designation at the moment. All that means, it's kind of a trick, but it isn't. It means that the Environment Agency has got to monitor those water levels so that we know that you can swim in it and you're not going to catch some horrible disease, okay? But the River Wharfe, I believe at the moment, is going through the process of trying to get bathing water designation. If you've ever been up to that part of the world in North Yorkshire Moors area, you'll know that people go in the rivers anyway. So ideally, it should be monitored, but it isn't because it doesn't have bathing water designation. The second thing, which is going to be really important over the next few weeks, is the fact that there's been lots and lots of storm overflows last year, and there will have been over the weekend that we don't yet know about. 13,350 were in the rivers, not in the sea. At least in the sea, you've got the tide, you've got a massive ocean, a massive sea for it to go out. The only place that the discharges can go is down the river. Okay, that's all it can do. So it's a really big issue. Over 300,000 spills from combined storm overflows, which again is absolutely appalling because we don't know what's going into the river at that point. And, you know, astonishingly, 91% monitoring. But these are only monitors that have of the hours that are spilled and how they were spilled. They're not constant monitors in the background, like, you know, you were saying. What we need real live monitoring, which we don't have. We know after the event what's happened, but we don't know now what's been happening. Okay, so we need live, accessible, legally enforceable data. I think this is the thing that you kind of missed a little bit of, but it's from my cybersecurity and networks background, so I understand it has to be legally enforceable. Otherwise, we can't support it. So all of these monitors, including turbidity, which hasn't been mentioned on there, dissolved oxygen, which measures the quality of animal and plant life. It's not just fish, it's all of the life that exists in the river. There's an example in, I think it's the biggest reservoir in the UK, which is Northern Ireland, where there was this massive green algae outcrop. That was caused by phosphates and nitrates going into the river, which encourages the growth of plants. Okay, and that meant that the algae could get a hold and it could suck all of the life out of the water, basically taking all of the dissolved oxygen out of the water and killing fish stone dead. And it's actually dangerous for us to swim in the water as well. So that lake then, which has got all of those chemicals in there, phosphates and nitrates in there, then has to be filtered out before it can be sent out of people's taps. So it's actually a very costly exercise for the water companies to allow this to happen in the first place as well. I hope they do begin to realise that. We can also measure things like total dissolved solids, which are exactly that, phosphates, nitrates and other, which are pollution determinants in the water, which is also important. There's a thing called biochemical oxygen demand, which is a kind of indirect way of measuring how much sewage there is in the water. I'm being polite. What used to happen with biochemical oxygen demand, it still happens now actually, it's a 5-day process. So what you've got to do, you've got to take a sample of the water, put it in a test tube, wait for 5 days, measure the dissolved oxygen in there, wait for 5 days, measure it again to see how much organic matter in the water has absorbed the dissolved oxygen. Okay, and then you know how much biochemical oxygen demand. You can actually do this directly now by a sort of third-party process, which means you can get live data about that coming out of the river as well. There's water depth sensors, which are fairly cheap. I talked to a colleague, Satria, about this, how he managed to do this in India, was it?
Malaysia.
Okay, Malaysia, sorry. And it's fairly straightforward, fairly easy to do. You just need the remote sensors to be able to make this work. Okay, this is what we've got at the moment. It's not as fancy as what you were talking about there, although it looks a bit like that seat that you had at the very beginning, I think. Okay, so where we are is we're using the people who own the riverbeds, which are the fishing clubs, and they are all over almost every river in the UK. This is one example just below Lady Bower. It's about 3.5 miles down from Lady Bower itself. I've actually taken a few people from Sheffield Hallam there, and for some reason they were a little bit impressed, because I guess it's smart sensor stuff, isn't it? There's a nice little fishing hut. Right at the bottom of the steps there is where the sensor sits. It's a bit of a backflow, but it actually has given us amazingly good data. Astonishingly good data. Some of it I hadn't realised myself would come out of it. There's the solar panel, there's the kit sitting up on a pole further up, which is relaying the information back to a central location. So this is how it works. We've got a sensor, we've got the endpoint, which is actually a device where we can send the data back either using 4G or satellite dish. In remote locations, you don't have, never mind not having Wi-Fi, you don't have 4G and 3G access. So 3G is going to be thrown out anyway soon, isn't it? You don't have 4G, 5G access, so we need another mechanism. And satellite dishes will do it. The only thing you have to do with a satellite dish is you have to batch it. Because what we want to do from the very beginning is keep it economically viable. Currently, I've noticed there are a lot of sensors around. I've done some research on this as well. There's a number of sensors, one from Northern Ireland company, about £3,500 each. That's just for the sensor before you start transmitting the data. We want to keep it well below that cost for everything, including the cloud data center at the back end, and including data analytics dashboard. I mean, we're using the semicircle type thing as well, green red. But that's up for grabs, because there's other better ways of interpreting the data as well. But ideally, what we've got is a lot of data that if you're in computer science and you're interested in this area, the data analytics on this is absolutely amazing. Currently, this is the website with the live data coming out through this, and please give us feedback after to let us know how you think we should improve it. I already picked up a couple of things from your talk, thank you. But this is an example of why I think it's absolutely amazing at the moment, and also incredibly useful. But unfortunately, we've only got the one. The top bit here represents, below Lady Bower, a depth, a water level meter that Severn Trent own. This is about where the sensor is. There's another water level meter here just below a bridge, but this is the important one because that's immediately below Lady Bower, okay? And the only water that comes out of Lady Bower is the water that Severn Trent allow to come out of Lady Bower, all right? There's no backflow from any other river, there's no other rivers coming in, so immediately below Lady Bower, where that is, this is the water that comes out of the reservoir. Last year, it was down to its lowest level. It was about 1/4 metre, lower than this, constantly all summer, up to about now. Remember last year we had a ban on hose pipes up until Christmas, was it? I don't know, I can't remember. And this year they're trying to get us to use more water. They should make it cheaper, shouldn't they? I thought it was a good idea. Anyway, what happened about here, what I've done is I've correlated the 2 dates. So these are almost exactly correlated. We've got temperature, which is the blue line, dissolved oxygen, which is the green line. And yeah, I'm pleased that somebody explained all the essence about oxygen as well. And I'll tell you what that problem is there. And you can see that there's a large outflow of water coming through. 0.75 metres, 0.79 metres, I think it came out of. And then it dipped down because I believe Severn Trent thought, oh, well, we're going to have some good weather coming up. That's fine. We want to keep the reservoir topped up because people need to drink, they need to bath, they need to shower, they need to do all the usual stuff. And then suddenly, we've got a storm coming, we've got a major problem on our hands, so we need to dump a load of water really quickly. And guess what? It causes flooding further down the road. There's actually another river that goes into the bottom of Bamford called the Noe. That actually contributes to it as well because it comes out of the hills and so on. So it's an additional problem that's got to be put into whatever analytics the water companies use. I'm sure they don't use particularly good ones, but nonetheless, they dumped a huge amount of water out of and it wasn't what's one, it's on a continuous basis. And that's what's caused the flooding. That's what's caused the flooding in Chesterfield. That's what's caused the flooding in Derby. The Derwent goes all the way down to the Trent. It's a long, long river. And if you're unlucky, this is what happens. So I'm not even sure that we weren't told at the fishing club that this had happened. We only found out almost immediately before it happened. And we are a very interested party because we're directly below Lady Bower, and you don't want to be swept downstream when you're doing some fishing, you really don't. So they haven't quite got their communication skills sorted out. There's another issue about the fact that there's only 2 monitors there, there's none of the River Noe and so on, so we don't even know the levels of the water that are going through it. What happened here was, over the short period of time, when there was lesser amounts of water coming out of Lady Bower, they're statutorily obligated to provide a minimum level, otherwise the Derwent dries up, which we don't want to happen. So they went down to the minimum level there. If you notice, the dissolved oxygen started going up and down until just before, or just at the point, when the mass of water came down the river, and the temperature stayed fairly stable, and I can talk about afterwards why that might be, but suddenly the level plummeted from about 10 milligrams per litre to about 5. Trout die at 4 milligrams per litre. They are pretty damn uncomfortable below 7 milligrams per litre. So if this had been sustained, they would have killed a lot of fish in the river. Not just fish, plant life would have been affected. There are crayfish in there. There are other animals that depend on the fish. There are even otters in the River Derwent. There is lots and lots of things happening in that ecology that make it a balance. And that's what happened. You can ask me, I've been told to move on. What are the takeaways? The takeaways are, we need the real-time data in our rivers, in all of our water sources. We need it to be trusted, so it's got to be cyber secure. It's got to be cost effective. It's got to be economic enough to make it work so that not just the water companies can afford it, but everybody, all the voluntary groups and so on can afford it as well. It's got to be widely installed in the river systems, otherwise it's not going to make any difference. It's not like a lake, it needs to be at different parts of the river system as well. All of these things, it's like the CIA triad for cybersecurity. It's got to be authentic, you've got to rely on the data, and the one that we're building and looking at, AquaSensor, we've designed it to be secure, and it works remotely, and it can be installed in lots of places, and it's all of these things, it's economic, etc. as well. Okay, sorry about going over a little bit. I talked about that a little bit too long. Thank you very much. Cheers.